first. Looking at a graph could be a great way to find the y-intercept. Could be. But looking at this graph, where does that cross the y-axis exactly? Really hard to tell. It's somewhere between -5 and -6. But where does it cross exactly between -5 and -6? I don't know. But if I could look at the graph and say, hey, I know that's going to cross exactly at -4, then it crosses exactly at -4 and we can move on. But sometimes we're not going to be able to just look at the graph and tell. So what do we need to do? We need to figure out a way to find the y-intercept algebraically. And I'm going to bring up a point here. That point right there, the coordinates of that point are 0, 8. That point is on the y-axis. The coordinates of this point right here are 0, 2. That point is on the y-axis. This point right here is 0, -3. That point is on the y-axis. This point down here is 0, -9. That point is on the y-axis. What do all those points have in common? The x value is 0. So the point we're trying to look for, this point that we're trying to look for, what do we know about that point?
0.
The x value has to equal 0. So how do we find the y-intercept? We set x equal to 0. Any point on the y-axis, the y value is what we're looking for. The x value has to be 0. So we're just going to set x equal to 0. So we take our equation at the beginning, and we get y equals 2 raised to the 0 - 2 - 6. All we have to do is plug in 0 for x. That came straight from the equation that I gave you in the problem. You can just type that straight in the calculator. You don't need a table. We're looking at one specific x value. The table gives us numerous x values. We only want one, so we're going to type that in the calculator. Y is already by itself, so I don't need to solve an equation or anything. And it's just -5.75. Where does our graph cross the y-axis? Exactly -5.75.
Oh, that's big.
Yeah, guess what? That works for any function, not just exponential functions, but any function that you ever might learn in Algebra 2 or College Algebra or Pre-Calculus, and they ask you to find the y-intercept. Guess what? You're going to do it the same way, because the x is always 0. What about the x-intercept? What about the x-intercept? If we were to look here at the x-axis this time, erase all this stuff. We don't need it at the moment. If we were to look at the x-axis, where do we cross the x-axis? Yes, sometimes it is good enough to just look at the graph and say, hey, I know it crosses the graph perfectly at x equals 5, and we can move on. But sometimes it's going to be like in between two numbers. And like, how far in between is it? We don't really know. But here's what we do know about the x-axis. We have these points on the x-axis. This would be 8, 0. This would be 2, 0. This would be -3, 0. This point over here on the x-axis might be -8, 0. What's true about any point on the x-axis?
The y is 0.
The y is 0. So this point that we're looking for, guess what's true about the y value? It is 0. So guess how we're going to find the x-intercept? We're going to set y equal to 0. Now, a little bit more complicated than the y-intercept. We can't just type this in the calculator like it looks now, because x is not going to be by itself anymore. So we're actually going to have to solve the equation for x. Actually going to have to solve this equation for x. So if we go back up and look at our equation, f of x, this f of x piece here, that is just y. And we're going to set that equal to 0. So we get 0 equals 2 raised to the x - 2 - 6. Guess what? That's an exponential equation. How do we solve exponential equations? We have to use logarithms. So we're going to add 6 to both sides. We got to get the base and the exponent by itself first. So we have to add the 6, just like we did before winter break, just like we did on our first test this semester. We solved a whole bunch of equations like this. Just like we did on those exponential growth and decay word problems, where we had to solve for time, just like you did in the Newton's law of cooling, where you solved the murder mystery, you had to find t the same way. So 6 equals 2, x minus 2. We can rewrite this as a logarithm. The base is going to be 2. And what's going to happen to the 6 and the x minus 2? They're going to switch places. So the x minus 2 is going to end up on the right side by itself, and the 6 goes inside the parentheses. Now, for most of us, how are we going to type that left side in the calculator? The fraction button. You're going to put log 6 on top, and you're going to put log 2 on bottom. And now that's equal to x minus 2. So we also need to add 2 to both sides to get x by itself. And that plus 2 absolutely 100% has to go outside the fraction. Well, can you put it on the top? No, that's not the same thing. You have to put it outside the fraction. So then you can type that in the calculator. Log 6 over log 2. We're going to add 2 to that to get x by itself. And we get about 4.58 if we round to 1 decimal place. About 1 or 2 decimal places. 4.58. Go back up and look at our graph. It looks close enough to 4.58. It's really hard to say exactly where it's at, but it does look pretty close. Okay with that? All right, let's do one more very quickly. We did number 5 yesterday. Let's find the y-intercept first, because it is the easier of the two to find. We're literally just going to plug in 0 for x. 0 plus 3 minus 1. Type that in the calculator. In your classwork today, if you create a table, because you're going to be making tables in order to graph them, the y-intercept is always going to be on the table. If you don't already have the table, just type it in. But if you have the table pulled up for this equation, you're going to have your x and your y values, and you're going to have like -2, -1, 0, 1, 2, 3. This right here where x equals 0 on the table, this y value is always going to be your y-intercept. So if you've already typed the table in your classwork today, in order to graph them, just find x equals 0 on the table. That will be the y-intercept. If you don't have the table typed in, type this in exactly like it looks. Guess what the table is doing? It's doing this. It's just changing 0 to 1 and to 2 and then to 3. But it's doing the same thing. Type that in the calculator exactly like it looks, and that'll tell us what the y-intercept is. I got a -1.125. -1.125. What about the x-intercept? What are we going to do? We're going to set 0, h of x or y equal to 0. So we get 0 equals -1/2 raised to the x plus 3 minus 1. -1/2 raised to the x plus 3 minus 1. We got to get the 1/2 raised to the x plus 3 by itself. That means the negative and the -1 have to go elsewhere. Which one are we going to move first? We're going to move the -1. We're going to add 1 to both sides. 0 plus 1 is 1. We get 1 equals -1/2 raised to the x plus 3. How can we get rid of the negative in front of the 1/2? We can divide by -1 on both sides. 1 divided by -1 is just -1. If you got a fraction, that would be okay. You could just leave it as a fraction. But we get -1 equals 1/2 raised to the x plus 3. The base in the exponent is by itself. So now we can rewrite this as a logarithm. So when we rewrite this as a log, the base is 1/2. What's going to happen to the -1 and the x plus 3? The logarithm is always equal to the exponent, so x plus 3 in this case, and the -1 is going to go inside the parentheses. And what are you going to type in your calculator when you type this in your calculator? You're probably going to put the log of -1 on top, and the log of 1/2 on bottom. So if you have your calculator, do me a favor and go ahead and type that in your calculator and see what happens. See what happens. You're like, well, you didn't subtract 3 yet. You're right, I didn't subtract 3 yet. I know I don't need to subtract 3 because you will get a domain error. And why did we get a domain error? We got a domain error because of this -1. What has to be true about the number inside the parentheses for the logarithm? It has to be positive. -1's not positive. So like, what's that mean? Like, it doesn't have an x-intercept. So anytime that we do this and we do it correctly, if we do it correctly and we get a domain error in our calculator, what does that tell me? That tells me that that function has no x-intercept. So in this case, we have no x-intercept. Guess what?
Shouldn't we'd be able to just tell that by looking at the graph?
If you already have a graph, yes, you should be able to just tell that by looking at the graph. So if we do look at number 5, is it ever going to cross the x-axis? No. So on your classwork today, if you have already graphed it and you look at that graph and you're like, there's no way it's going to cross the x-axis, do you need to do all of this work? No, you don't. Just write no x-intercept because it literally does not cross the x-axis.